So you got yourself some wires and you got a bunch of these little thingies. You know what those are? You know how to use them? Well, after this video, you're going to be a pro. Hey everybody, how's it going? This is Patrick with Stacking Layers. Today I'm going to take a little detour from my standard how to set up these things in firmware and all that good stuff. And I'm going to show you how to properly set up wiring for these things. Something that I've noticed in the community quite often is people having problems with burning up these terminals or just having really poor connections or really using the wrong type of connectors in general and causing lots of problems. So I figured let's help out the community and let's get these things set up properly. So what's going on? Well, if you don't know, these things are screw terminals. This is where obviously your power is coming in. And if you do this wrong, you can run into a very dangerous situation. This is not a very high voltage system, obviously. So a lot of people don't think about the potential of fires or things like that until they come into think maybe like their heaters. Obviously, those things get really hot, so that can be a fire source. Well, you may be surprised to find that these can also be a very big source of a fire. And actually, a lot of printer fires have happened because of this situation. So what am I talking about? Well, a lot of cables will come, especially for the power input, they will come with solder. Now, this is just, I'm just holding it. It's not soldered on here. But a lot of them will come, especially from the factory, they'll come soldered. And the reason why they do that is just because it's a nice, easy way. They dip them in this nice, clean, keeps the wires from fraying out, you know, to doing this type of thing in shipping, which would look, obviously, would just look terrible if you get your wires and they look like this, right, on a new product. But the problem is that if you're not going to solder down, so, you know, obviously solder is solder, you know, all these little points, right? If you're not going to solder wire directly and leave it like that, you do not want solder on your wires. Solder is perfectly fine. Obviously, we use solder everywhere on these things and they don't burn out. But what happens is when you put solder under pressure, so if you have solder on the tip here and you put it in there and you clamp down, as you put pressure on, the solder is soft enough to actually create stress cracks. And those stress cracks will cause resistance because it does have a slight air gap where it's barely touching. And any type of resistance you get in there is going to create heat. Well, what do we know about solder when it heats up? It starts flowing. It's not going to heat up right away enough to melt the solder, but it will heat up enough to where the solder will continuously droop or flow out. It'll like get thinner and it'll create more cracks. And it'll also make it to where that the clamp that you originally had on there is no longer tight and it starts creating a gap on the clamp also. So any of those gaps that you get will cause resistance. And resistance will cause heat. So if you don't know how a resistor works, basically, is it limits the current by slowing down the flow, or what it's actually doing is converting the current into heat. It stops it, it clamps down onto the flow of electricity, and that creates basically the way it gets away and where it puts that power, because you can't just get rid of the power, it doesn't stop it. What it does is it converts it into heat. And in a normal system, a proper resistor, proper system, that heat's not going to be not going to be too dangerous. You'll be able to feel it. Obviously, we know electronics, when they run, they do warm up, right? That's why we have fans on things. But with this type of system, that's not supposed to be heating up. You're not supposed to have resistance on there. And so you might think, well, okay, wait, why is that burning up? Well, I have a fuse right here. Why isn't the fuse going? Well, again, it's not drawing more current and it's not short circuiting. All it's doing is dissipating heat through the resistance. So it's not enough current to blow the fuse. Also, these fuses, if you notice, this one says it's a 20 amp fuse. It's not enough current anyways to blow that. This is designed to protect the power supply from a short circuit. So if somehow you have a short circuit within your main power supply, that's when the fuse will go. So if you have something, for instance, your bed gets shorted out, that's going to pull all the current that the power supply is able to give out, which normally is more than its rated system. The rating is like the maximum you should run it at, but it can actually supply a lot more. And that's why these things blow out. So it's to protect your power supply from having an overrun, an overcurrent, or a overload, basically. So that's why that there's no way of knowing, or for the system, that's why it won't protect you. That's why they melt down, and you can cause fires by melting these things down. There's other things like thermal runaways with your thermal systems, your what is it called, the heating and your thermistors. That's a different type of thermal runaway. That's basically a logical system saying, well, you're telling me to heat the heater up, which will be connected on one side, like right here, right? You're telling the heater to go to 100 degrees, but the thermistor is saying it's only at 60 degrees. Well, that's a big difference. Let's shut down because something's not right. Or the opposite. you're telling it to go to 200 degrees, but the sensor's reporting back 300 degrees. Well, obviously, whether it's bad or not, that's the wrong temperature. That's way higher than it's supposed to be. Again, the logic system is able to see the two differences of what it's asking for, what it's receiving, shuts down. These things have no feedback. They have no way to report to the logic system that it's getting too hot. And that's why you can get these meltdown systems. Okay, so enough of that. I think you understand what I'm talking about there. So what's going on with these wires? How do we get these things from burning down or not burning down? Keep them from happening. Keep that from happening. So first I want to say is, like I mentioned already, cut the solder off. Don't use solder in clamps. I'm sure if you watch my videos, you hear me harping on that constantly. It's because that's probably the #1 source of these problems. So it is perfectly fine to use bare wires in these clamps. They are designed for bare wire. They are more specifically designed, though, for solid core bare wire. So that's why Ferrules come into place. But before I talk about those, I do want to point out, like I said, it is perfectly fine to use that, but these are what you need to pay attention to. One is how much wire you have stripped off, or how much insulation you have stripped off, how much bare wire is available. So when you get them in there, you want the bare wire to be long enough to where it hits the back. I don't know if you can hear that, but it's hitting the back of the terminal inside here. I can't push it in anymore. And at the same time, there's a very slight amount of metal still exposed. Can you see that? Right? The insulation is not inside the block. That's the perfect way of doing it, because that lets you know that you're not pinching insulation. Because if you get it too deep in there, so if, for instance, it goes in and your wire is like dark like that or whatever, you can't see any of the bare wire at all, then there's a potential of you pinching the insulation. The insulation is going to cause a gap. What does the gap do? That's right. It causes this to heat up, just like with having solder, because you're not getting a perfect connection on there. Anytime you get a bad connection, you will generate heat. So if you're going to be using bare wire, make sure that there's a tiny bit showing so you know your insulation is not pinched. Okay? So that's perfect enough to do it. And then when you go and tighten it down enough to where obviously the wire's not falling out, but don't keep tightening it so hard that you start seeing these things twist. If you see these things twist, then you're putting too much torsion on there and too much torque, and you can actually cause back here the solder joints to crack. And again, a crack in the solder is going to cause heat, going to cause problems. Okay, I think you're getting the theme here. Heat is bad on these things. You don't want to crack your stuff. You don't want to have loose connections. So when you're tightening these things down, especially when there's only 2 of them, it's a good idea to give a good firm hold on the system. But mainly, don't go all He-Man on these things. You don't need to torque them down so much that it's impossible to open them up again. It doesn't need to be that tight, but it does need to be tight enough that it's not going to fall out. It's not going to vibrate itself loose. And if you do that, you can occasionally, if you want to set up like a monthly or every 2 months, come in and double check. Just give it a little bit of a twist to make sure that they're still tight. That's a good safety way of maintaining your system. So something about the Ferrules, why you would want to use those is, again, like I said, since you can use these wires, that's great. But if you have this already installed in your system and you're installing the wire and you're down here fiddling, you're trying to get it in, and you get it in there and you clamp it down, and you're all good to go. Well, let's take a closer look at what happened here. As you can see, some of those wires moved to the wrong area. They got pushed out because it's very difficult, nice, really tight down inside of your machine. Well, obviously you got this, a couple of them are actually in the wrong side. So you can get short circuits again, which will may not actually blow any fuses because of how thin these wires are. All they'll do is heat up. And those little bits of heating up, because most of your current's going to be flowing through the main part, but a little bit will go through there. And the smaller the wires, the more resistance, so the faster they'll heat up. But again, it's not going to draw enough current. It's not going to destroy your system right away, but it will cause heat, and that heat will radiate through. It'll start melting things down, and it'll cause another thermal runaway. So that's why we're using Ferrules. So I'm going to show you how to get those properly installed and what's the difference on. But before we do that, I want to give a huge thank you to my channel sponsor, PCBWay. So let's jump in, a quick video about them, and then I'll show you how to get these done. If you're someone who loves tinkering, designing, and creating, you'll definitely want to check out PCBWay. PCBWay isn't just about PCB manufacturing. They've got a wide range of services to cater to creators just like you. From crafting intricate prototypes using many forms of 3D printing to precision machine parts through CNC machining and so much more, PCBWay has got you covered.
A really nice part is their online quoting system. It lets you see the cost estimates for the services you need, allowing you to plan your projects without any surprises. As for quality, PCBWay takes it seriously across all their services and do their best to ensure all your designs will meet the highest standards. Beyond services, PCBWay offers a supportive community. Their forums and dedicated support team are there to help you to navigate through your creative journey. If you're intrigued and want to know more about PCBWay services and how it can benefit your projects, check out the link in the description. I want to give a big thanks to PCBWay for sponsoring this video, and now let's get back to the video.
Okay, welcome back. Let's get these things done. Now, ferrules. What are ferrules? Ferrules are these little guys here, if you didn't know already. These are a great little invention, a very simple tool, and all they do is convert these type of wires, these ugly stranded wires, into something nice and solid like this. Because technically, this wire is going to give you the best connection or the best electricity flow, because it's a big solid wire, and the bigger or more solid the wire, the less resistance there is, basically. But the disadvantage, obviously, is that these things are solid. They don't like to flex. And if you do somehow get them into a system where they're flexing around, it'll eventually crack because it's only a single line. And what does that crack do? Yep, it creates a gap, which creates heat, resistance, all that good stuff, and you'll have a thermal runaway inside your wire. You'll get a meltdown there. So that's why, obviously, we use these stranded wires. These stranded wires tolerate a lot more motion because of how thin the wires are. And when they're grouped together, they hold on to each other really well, and they keep each other from breaking. And so that's why we use ferrules. So what the ferrule does is once you have the right sizes, it solidly brings all those things together. If you notice, it looks like you have a solid piece of metal inside there, which basically is like that, right? It looks the same virtually. So using a proper size ferrule is a beautiful thing, because now you have an amazing solid connection to clamp down on top of, and you're not going to have any gaps. Well, this is where a problem, and where I see a lot of people using these things completely wrong. So obviously there's tons of different sizes, but if you don't use these on a regular basis, you may just go ahead and buy a small little pack because you don't need many of them, and you'll get one that looks like, okay, that's going to fit most of the wires I have. Well, these things are basically a one size fits one, maybe a one size fits two type of thing at the most, but these are not one size fits all. You can make them fit, but I will show you why that's a bad thing. So I'm going to use this as a demonstration. So we got this big guy here. This one is made for a 2.5 millimeter, or what would that be? A 14 gauge wire. So basically what this is. And that's great because that obviously we know fits. But let's say you don't have a 14 gauge, but you got something like this one, which is more of, or let's get something like this one here. So this one is a very commonly used wire for small lines of power. And this is a 0.5 millimeter, which is, I think, like a 20 gauge wire. Sorry, I'm using metric and stuff, but I think you get the point. So, you look at it and it's like, yeah, I could fit in there, and you put it in and it seems fine. You can get it to line up and stuff. But if you notice, I'm able to push this all the way through, right? If you can push it all the way through, do not use that ferrule. That ferrule is way too big, and you can run into problems. So what I'm going to do is go ahead and clamp this down, or sorry, crimp it, get it into place. So we got a little bit sticking out. So we know the wire is all the way through. Go ahead and cramp it. I keep saying cramp. Clamp it down. Crimp it. It's a cramp. Yeah, anyways. So you can see it's got all these weird ridges on it. It's folded over on itself. Hopefully I can get this on the camera there. So you see, like, it has like this little spur effect going on. And you can see the wires in there are not very tight when you compare it to the way the other one looked. This is the proper size. So you can see how big of a difference those are there, right? So the one here on the left is kind of like this weird star pattern on the outside, and then none of the wires are tightly packed together, whereas this one is solid, and the edges are nice and smooth, right? So these edges are nice and smooth, whereas these are all ripple-y and folding in on themselves. So this one, even though the wire is in there, it's nicely held in place, it's not going to give you a good connection. And what happens is when you start clamping down on this thing and actually cause the tube to flex out, which will loosen up the inside. And again, right back to your same problem, loose connection is going to cause heat. So you want to make sure that your wires are set up in there properly. Another issue you can have, here, actually, I made a mock-up so I can show you, demonstrate visually here. Go over to here. This is Fusion 360, and I just made a model, 3D model of these guys. So this is what I'm talking about with the right sizes. So this side here, the left side, is the correct size, where obviously this one is not. These two would be like the blue ones I showed, and then the two wires, right? Makes sense. So I have it set up to where these things will interface with each other to where if I hit, so I bring it down, it stops. I can't pull it any lower. So that's like the real life. The insulation is meeting the bottom here, and that's it. All right, and you got a tiny bit of wire sticking out the top, which is perfect. That way you know that your wires come all the way through. Now, I got this one, obviously, too big, like I was showing you with the real wire. But then let's get it to where we measure up. We're like, I'll be good. I got just a tiny bit of wire sticking out. I should be fine. You clamp it down. Well, let's see on the other side. I cut these things in half so you can see what's going on inside. So here now, obviously, the one on the left is the thinner one, the wrong one, and this one on the right is the correct one. So again, it goes there. The insulation bottoms out just before the little funnel gauge for your wire. And if you clamp down, wow, why do I keep saying cramp? If you clamp down on this, you're going to get a good solid connection right there, right? But on this side, look what's going on there. This is where you would clamp down when you crimp it. And obviously, the insulation is now inside the tube. Let's zoom in here. You have the insulation inside the clamping area, right? So what that's going to do is cause the crimp tool to stop putting pressure on it because it's designed to only put so much pressure on there. But because that insulation is in there, it's going to stop so far in, and you may only get it to like, say, like to here. It'll only be so deep. Or maybe it does go deep enough to where it starts holding onto the wire. The problem is that it's going to be bowed in, it's going to be all choppy in there, and these wires are not going to be pressed together like a solid piece of metal like it should be. And of course, what is that going to do? Cause a gap, cause resistance, cause thermal runaway. You will cause heat. So that's why it is vital that you use the right size. All right. So that's the main point of this video here. Use these things properly, and you're going to be having a perfect time with your printer. You're not going to have any issues with all of those clamping and whatnot. Here's a couple other things I wanted to mention, just so you know. Now, say for instance, you have your terminal. Actually, let's go over and I'll show you an example in the real life here. So we got these bigger guys. These are nice because these are big solid things. And let's see, we got something like this long one here. And it goes in, and it pretty much goes in all the way, right? But if we have something like this little guy, those are much smaller. And so you go and get them in. Actually, that one's too big. Maybe this one. You go and try to put it in, and then that's it. It won't go any further. So you got this much larger amount of exposed area. So basically you can cut these things. So go back over to here. As long as you have it properly inserted, you'll notice that all the metal is here, right? So if you go ahead and just snip off the tip like that, cut that part off, you'll be good because you'll still have all the solid metal. So I'll demonstrate that. Let's see, what we'll do is I'll kill two birds, one stone. All right, so before I show you that, I will show you that there are different types, which you may have noticed already. So we have round ones and flat ones. These flat ones are actually designed for a very specific purpose, and that is to join two wires into one area. Don't use the round ones. I mean, you can make it work. You can squeeze them down and make it work, but it's not recommended to use two wires in these round ones. But with these flat ones, they're designed for joining two wires. So I'm just going to fold this in half, but that's what it's made for. And again, they are specifically designed for certain sizes. So that's what this one is designed for, this one here, which is a 20 gauge, the half millimeter. Let's just go ahead and get some of these off. Okay, so we got some exposed wire. Now, when you use the doubles, I recommend to cut a little bit extra than you need. That way you know that both of them come through. Okay, so all you do is you crimp them off. Also, before I put that in there, don't twist when you're using these ferrules, don't twist the wires. Leave them straight or however they come out of the wire. Because if you twist them down, what happens is that it can actually cause this to get wider, which will make it so they don't fit very well inside. That's just the insulation thing. It's not going to damage anything, but it's going to make it difficult to install. So you go ahead and get these both in there, make sure that nothing is frayed out, and then you go ahead and get them in, of course. And as you can see, you can see where one of them is in lower than the other, so you can make sure that they're both sticking out. And that's why I recommend to have them a little bit longer than you need. You can always snip that off. So that's what those are made for. You get those crimped in. And I recommend the 6 mandrels. There's other ones that have 4. They work perfectly fine too. But the ones with the 6 have more surface area to clamp down on. So those are nice to have. They give it more of a round thing. Although sometimes the 4 ones are nice for some of these because they are square holes in here. So the 4 mandrels, the mandrels are little silver parts that move. The 4 ones could also work too. I just like the 6 one, so it gets a nice rounder thing. That's personal preference for me. But anyways, as you can see there, there's a nice smooth outside. Obviously, it's got the shapes on it, but it's not buckled in on itself like the other one was. Where did that one go? You see, you can obviously see the difference there, right? This one's all rigidy and whatnot. And then if we go and cut this, you will be able to see. Actually, before I cut this, I'll show you. Sorry, bouncing back and forth here. So here you go. Got it in, but obviously that's as far as it goes. It won't go any further in. There's too much metal sticking out, right? So it's perfectly safe as long as you have no insulation in there. Perfectly safe to come and clip off the tip. So I noticed that I had 2 of these little ridges sticking out, so I can come in 1, 2 of the ridges. It's a good way to gauge how much you need to clip off. So now I got this little bit, and we'll double check there so you can see inside. See how shiny that is? That means you got a perfect crimp on there. The right size has been used. No gaps whatsoever. But we come into here, and you push it in, and now we got it in. And you can see there's still a tiny bit sticking out, which is good. I'm bottomed out in the back. And that would be the perfect size and the perfect length for that terminal. And again, go ahead and tighten it down, but not so tight that you start twisting this whole housing. Just enough to hold it in place snugly. And that's how you do it. So that's the gist of it. That's pretty much all you need to know about these things. Do not go back over here. Do not do this. Do not get the giant ferrules, or do not get enough to where your insulation is able to come through. Basically, don't use any ferrules where the insulation is not going to stop like this does here. And don't use it, even if it does stop, say it's just big enough to where it stops right at the edge here, but you still have all this loose wire, because keep in mind, sometimes insulation is a lot thicker on certain wires, but the wire is still very thin inside. So you need to pay attention to that. If the fact that your wire is very thin with a very chunky insulation, on some cheap wires, it actually gets really big. I don't know what they're doing, but I think they make it look like you have a bigger wire than you do, than you ordered. So maybe it says like it's a 1 millimeter wire, or what would that, the 18 gauge wire, but it's actually 20 gauge inside. That happens. So be careful. Pay attention to that. But basically, if your wire, your actual metal conductive zone is not filling up as much as possible inside there, that's still too small. So say, for instance, this wire was inside this insulation, obviously it's going to stop, but then there's just not enough in there, and that's going to be a bad connection. So pay attention to that stuff. You can always do a dry run, and like I've been doing here, where I go ahead and cut a little piece. We'll get back over here, and I'll use an extreme example. I got a tiny wire here. This is about a 22 gauge or so. So this is a really tiny wire. And then I'm going to go ahead and put it in the stupid, obviously you wouldn't do this, but a really large one. But, hey, I got it lined up. All right, nice and lined up. It's not going to pinch the insulation. This would be an example of the insulation doesn't go through the tube, but the wire is obviously very small. Let's crimp that down. And it feels solid in there. But if you start looking at it, look at that mess. Can you see all that? See how it's all rigidy and folded in on itself. And then if we go ahead and cut this open, let's see how that looks inside. You can see inside there, it's still very granular, right? Compared to, where did the other one go? Compared to this. You see the difference, obviously? This one's nice and full, solid, there's virtually no air gaps, whereas this one is still, it looks like just bare wire, right? It's still moving a lot. It's still very choppy inside there, and you know, it's too many gaps. It does have a good, oh, actually it doesn't have a good connection. Notice I was able to pull that right out. So there you go. There you go. That's how you, that's good proof. That wasn't even enough to continue holding on. So over time you get some vibration, that's going to start coming out. So there you go. That proved the point. All right. So that's it. That's the safety. That's why and how you crimp. That's, you know, I can't stress it enough. Do it right. You're not going to have any meltdown. You're not going to have any fires. These things are going to last a long time. Honestly, I have never had a board burn up on me. And I've seen plenty of people with this exact board with melted terminals. So I know that, you know, with as much as I've messed with this board specifically, this board has been through torture. I've used this thing wrong, essentially wrong, so many different times. I've reinstalled and moved it around. It's never been in a case. It's always been handheld like this with no, you know, electrostatic protection, anything like that. I mean, this is really the worst case scenario, the way I handle this thing. But I do make sure that all my connections are always as good as I can possibly get them. I've never had an issue. So it's definitely doing it the right way is going to make your system last forever, essentially. All right. All right. So now you should have a good understanding of how these little furrows work and how to use them the proper way and things you should not be doing. Hopefully that makes all sense. If it doesn't, leave it down in the comments. Let me know what doesn't make sense, or if you have any more questions about it, I may have missed something. Leave the comments. I love reading them. Even if it's bad stuff about critiquing my channel, it helps me out learn more of what you guys want to see. So do that. A huge thank you again to PCB Way. They don't do just PCBs. Here is a resin sign that they made. Look at that thing. I mean, it's impressive what they do, right? This is resin. This isn't acrylic. So they do more than just PCBs. If you want to get some resin stuff made, but you don't want to mess with the stink of a resin printer, you can do it. Now you can have resin stuff made for you. Or if you want to get some metal printed things, they can do SLS printing or different types of metal printing. They can also do CNC, sheet metal bending, all sorts of stuff. So your imagination is really the limit when it comes to them, and they're great people to work with. So I recommend checking them out, link in the description. And a huge thank you once again to all of my subscribers. You guys are amazing. Thank you, thank you. Thank you for all the new people coming in. And a special thank you to everybody that's been here from the beginning. This means so much to me. I'm going to be doing more stuff like this with the hardware because I know I've been focusing a lot on firmware, but I do really want to make sure that I get more bases covered. So that's why I started doing this. Plus I saw this just needed to be addressed. So that's why I focused on that one today. More to come. So subscribe, like if you like this stuff, share it if you know anybody that's looking for this type of help. All right. So that's the video. Again, any questions down in the comments. And until next time, get out there and make something. Thanks for watching.